BmTx3 is a neurotoxin, which is a component of the venom of the scorpion Buthus martensi karsh. It blocks A-type potassium channels in the central nervous system and hERG channels in the heart.
Source: isolation.
BmTx3 was originally purified from the venom of the Chinese scorpion, Buthus martensi karsh. BmTx3 is a short-chain peptide like other potassium channel blockers in the scorpion venom and added to the phylogenetic tree in the subfamily alpha-KTX15. Its 3D structure has not yet been elucidated, but based on sequence similarity it likely resembles the 3D structure of BmTx1 or discrepant.
Biochemistry.
BmTx3 consists of an alpha helix and two beta sheet segments cross-linked by three disulfide bridges Cs alpha-beta motif. It is a short-chain peptide with a molecular mass of 3,751.6 daltons. It consists of 37 amino acids.
Target.
BmTx3 is the first toxin from the scorpion alpha-KTX subfamily 15 with two functional faces. As all alpha-KTX peptides, BmTx3 blocks A-type potassium currents Kd.
54 nm. BmTx3 blocks primarily the Kv4X proteins and has a higher affinity for Kv4.1 channels than for Kv4.2 and Kv4.3 channels. The second functional face of BmTx3 blocks the hERG human ether agogo channel Kd.
2μm, a characteristic belonging to gamma-KTX peptides. BmTx3 binding site seems essentially localized in neurons but could also be present in glial cells, endothelial cells and/or arterial smooth muscle cells. The distribution of BmTx3 binding sites is heterogeneous. A high density is found in the caudate putamen and accumbens nucleus, thalamus, hippocampal formation and cerebellum.
Mode of action.
The functional face of short-chain scorpion toxins is built of two important dyads, lys and tyr, on the beta sheet side. Lysine plugs deep into the channel pore and tyrosine, as penultimate or ultimate and hydrophobic residue, turns it to fixate it, leading to a physical occlusion of the channel pore. This is supported by the finding that deletion of the two C-terminal residues SBMTX3 delip results in loss of ability to block EA current. The other functional face is thought to be situated at the alpha helix side and composed of ARG18 and Lys19, like the functional face of other hERG toxins. It is known that alpha-KTX peptides use the beta sheet side to interact with the receptor, whereas gamma-KTX peptides usually use their alpha helix side. As BmTx3 seems to use both sides to bind to different potassium channels, it might be an evolutionary transient between the two families.
Toxicity.
When injected into mice, it causes epileptiform behavior. This might be due to its effect on A-type K+ channels, which, like the Kv4X, are involved in action potential backpropagation, firing frequency, spike initiation and action potential waveform determination. Blocking of the hERG channel can cause drug-induced long QT syndrome, arrhythmias and ventricular fibrillation which can result in death.
References.